I want to tell you about the most expensive excitement I've felt in a while. On August 10th, Meta drops Muse Glimmer 30B completely unannounced. No countdown, no waitlist, no sign up to be notified. It's just here. And the benchmarks they published looked impressive. Better than Qwen on agentic tasks, they said. Competitive with models twice its size, they said. I have dual RTX 3090s sitting on my desk. That's 48 GB of VRAM combined, and a custom agent framework I've spent months building. Within about 20 minutes of the announcement dropping in my feed, I was already pulling the weights. I was excited. The kind of excited where you stay up way past when you meant to because you want to see one more result before bed. And then I wired it into my actual work. And I watched it confidently interpret move a file as copy a file and leave the original sitting there forever. So in this video, I want to give you the honest version of this story. The setup, the speed numbers, the real benchmark, which is not Meta's benchmark, but my actual workload, and the conclusion I came to after a weekend of testing. Because when a company drops a model with this much energy behind it, someone has to actually put it through the grinder and tell you what happens. Let me tell you exactly what I ran, because this matters. When a new model drops, a lot of people do the minimum viable setup and then complain the model is slow or the quality is bad. That's not what I did here. I wanted the absolute best experience before I judged anything. So I downloaded the Unsloth Q8 GGUF. That's maximum quantization quality, the closest you can get to full precision on consumer hardware without needing a data center. Then I paired it with the BF16 vision projection file, grabbed the default Kquant DiaFlash drafter model for speculative decoding, and also the latest llama.cpp build from source. Basically, I rebuilt it from scratch for my dual 3090 setup and fired up the server. For those who've never done this before, Q8 means the model weights are stored at 8-bit precision instead of the usual 16-bit or 32-bit. You lose a tiny amount of quality, but you cut memory usage in half. On consumer hardware, this is how you fit big models into real GPUs. The BF16 vision file keeps the visual components at higher precision because compression hits vision harder than text. And speculative decoding, the DiaFlash drafter, is a trick where a small fast model predicts the next several tokens before the main model confirms or corrects them. It sounds like extra work, but it makes the whole system faster. Everything loaded cleanly. No errors. No drama. Which, honestly, is not always how this goes. I've had afternoons where getting a model to load correctly consumed more time than actually testing it. So that part was a genuine win. Now let's talk about speed, and I want to be fair here before I get to the part where things go sideways, because the speed numbers are impressive, and they deserve credit. On my dual 3090 setup with the full Q8 configuration, Muse Glimmer 30B generates at 50 to 60 tokens per second. Cold start prompt prefill runs around 1,500 tokens per second, even at 50,000 tokens of context, which is a long conversation with a lot of accumulated context. Prefill stays around 1,200 tokens per second. The DiaFlash speculative decoding overhead is minimal. The whole thing feels smooth. For reference, 50 to 60 tokens per second on a 30 billion parameter model is fast. Fast enough that in a chat interface, you're watching words appear faster than you'd read them naturally. The latency feels close to zero in practice. And for basic daily work, moving files, running Git commits, writing simple functions, answering questions, it absolutely holds up. You'd be happy with this speed if this were all you needed from it. I don't use AI models for basic daily work. I use them for the hard stuff. I wire them into agents and put them to work on complex, multi-step tasks where speed is table stakes and reliability is what actually matters. And that's where the story changes. I need to explain how I actually tested this, because it matters for interpreting everything that comes next. I have a custom agent framework. It's entirely custom code. No model has ever been pre-trained on it, which means every model that gets plugged into it starts from the same zero baseline. There's no home field advantage. It's just the model, my system prompts, my actual tasks, my actual workflows. I've already run DeepSeek v4 Flash and Qwen 3.627B through this same pipeline. Both of them handle my workloads well. Both follow instructions reliably. Both behave the way you'd want an AI agent to behave when it's doing real work on your behalf. That matters for what comes next. Because when Muse Glimmer failed tasks that those other models handle easily, I didn't spend time wondering if maybe my framework was the problem. The framework is the constant. The model is the variable. When the model fails where other models don't, the model is the problem. And Muse Glimmer failed in some ways I didn't expect. Here's what that actually looked like in practice: 6 specific failures, in the order I ran into them. Failure 1, it ignored the tmux instruction. My system prompt is explicit about this. For any task longer than 30 seconds, start a new tmux session in detached mode. This is basic operational hygiene for an agent running on a server. You don't want a long-running command to block your entire session while you're waiting for it. Qwen follows this without question. DeepSeek follows it without question. I've never had to think about it. Muse Glimmer ran the command inline, blocked the whole session while a large file transfer crawled through to completion. No tmux, no detachment. So I retried it with a slightly different prompt and got the same result. It's not a one-off glitch, it just doesn't reliably follow that instruction. Failure 2, it doesn't know what move means. This one surprised me, and I want to describe it carefully because it sounds too simple to be a real problem. I asked it to move a large model weight file from one server to another. It copied the file, left the original sitting in the source directory. When I asked why the source wasn't deleted, it told me, and this is a real quote, "I interpreted move as copy." I stared at that for a moment. Move means copy plus delete. This is not a subtle semantic distinction. This is the definition of move in every file system context ever. Even Windows Explorer knows this. My agent framework definitely knows this. Qwen and DeepSeek have never once made this error. Only when I explicitly typed delete the source file after copying did Muse Glimmer actually do what I originally asked. I have a college friend who used to clean up his desk by shoving everything into a drawer. This is the AI equivalent of that. Failure 3. So I wanted to use Muse Glimmer to help control ComfyUI, editing workflows, creating custom nodes, debugging JSON structures. This is exactly the kind of coding task where benchmark scores are supposed to mean something. The Python it produced didn't run. Not ran, but had a bug. Didn't run at all. I had to hand the problem to DeepSeek v4 Flash to fix what Muse broke, which is not the workflow I was hoping for. Use one model to generate broken code, use another model to fix it, is technically complete but spiritually wrong. Failure 4, the context window, is the real problem. This is the one that matters most practically. Muse Glimmer's context window is 131K tokens, compared to Qwen 3.627B, which supports 262K. DeepSeek v4 supports 1 million. 131K sounds like a lot until you're running a real agent workflow. Deep search across multiple sources, accumulating tool call results, tracking the state of a complex task. My framework has an auto memory compaction trigger set at 50% of available context. On Qwen with 262K, compaction kicks in around 144K tokens, which still leaves another 100K of runway for more tool calls, more search results, more work. On Muse Glimmer's 131K ceiling, you're triggering compaction at 65K tokens and then running out of room fast. Simple tasks with limited context? Fine. Complex research workflows that accumulate a lot of state? The model runs out of room before the work is done. Failure 5. It ignores citation rules. My agent has a clear instruction. Always keep source links in the final output. This is non-negotiable for research tasks. Citations are the difference between useful output and interesting sounding noise. Muse Glimmer dropped all of them. Not half, not some, all of them. Clean prose, no citations. Output that can't be verified and can't be trusted for anything that matters. Not a capability problem, a simple instruction following failure. Failure 6. The analysis has no depth. This one is the hardest to quantify, but the most obvious when you see it. I put Muse Glimmer through multi-topic research tasks, the kind where you search multiple sources, synthesize findings, and draw conclusions. It found accurate information. It summarized cleanly. And then it stopped. Qwen takes it further, connecting dots between sources, offering predictions about where things are heading. DeepSeek goes further still. Not just information and predictions, but actual synthesis that makes you think differently about the topic. Muse Glimmer just rephrased what it found. Very accurate. Very clean. Nothing you couldn't have gotten by reading the search results yourself. There's a term for a system that accurately reproduces information without adding any insight. It's called a parrot. A very fast, very confident parrot. Muse Glimmer 30B is not a bad model. It's a capable model for the right use cases. If you're doing casual chat, light coding work, creative writing, or basic question answering, you'll be happy with it. The speed at 50 to 60 tokens per second is real. The Q8 quality is genuine. On dual 3090s, it loads without drama and runs without lag. But Meta made a specific claim. They claimed this model surpasses Qwen on agentic benchmarks. In my actual agentic workloads, it doesn't come close. My honest read is that it performs closer to Qwen 3.535B, the MOE architecture from the previous generation, not the current Qwen 3.627B it's supposed to beat. The gap shows up in 4 specific ways: instruction following reliability, context window depth, reasoning quality on complex tasks, and the ability to follow operational rules in a system prompt. On all 4, Qwen 3.627B is clearly ahead. On speed, Muse Glimmer has an edge. That matters. I'm not dismissing it. But for serious agent work, speed without reliability is just failing faster. Here's the framework I've started using for evaluating any new model. 3 questions before the benchmark scores matter. Can it follow unusual but explicit instructions in a system prompt? Can it handle tasks that accumulate a lot of context before they complete? And does it actually synthesize, or does it just repeat information back to you? Muse Glimmer passes on speed. It struggles on all 3 of those questions, which tells you what kind of workload it's suited for. Which brings me to the bigger point, the one that applies every time a new model drops with a flashy benchmark page. Benchmarks are advertisements. I don't mean that cynically. I mean it literally. A benchmark is a controlled test designed by the people who built the model on tasks the model has been optimized for, measured in ways the lab chose. It will always show the model at its best. Your actual work is the truth. Your specific tasks, your system prompts, your tolerance for instruction following failures at 11 p.m. when something needs to ship. If Muse Glimmer fits your workload, fast generation, light agentic tasks, dual 3090 setup, tasks that don't accumulate huge context, run it. The speed is real and the setup experience is smooth. But if you're comparing it against Qwen 3.627B or DeepSeek v4 Flash for serious multi-step agent work, do the comparison on your own tasks, not on Meta's benchmark page. If this video saved you some testing time, or at least made you feel better about your own failed setups, hit the like button. Subscribe for more honest model breakdowns like this, and drop a comment. Have you run Muse Glimmer? What did you find? I want to know if others are seeing the same instruction following gaps, or if my workload is the edge case. See you in the next one.